Hey there, science fans! Today we're diving into the world of electronics with a fantastic tool, the Cathode Ray Oscilloscope, or CRO for short. Imagine a device that lets you visualize electricity, like a heart monitor for your circuits. That's the CRO. It's like having X-ray vision for your electronics projects. The CRO is essential for anyone working with electronics. It helps us analyze signals, troubleshoot circuits, and understand how electrical components behave. By displaying voltage changes over time, the CRO provides a window into the dynamic world of electrical signals. Whether you're a budding engineer, a hobbyist, or just curious about how electronics work, understanding the CRO is like having a superpower. Get ready to unlock the secrets of electrical signals. Let's start by measuring voltage, the pressure that drives electrical current. Think of it like water pressure in a hose. First, connect your signal to the CRO's input using a probe. It's like plugging in a lamp. Now adjust the vertical scale, volts, division, to fit the signal comfortably on the screen. You wouldn't want the signal too big or too small, right? The peak-to-peak voltage, the difference between the highest and lowest points of the wave, can be measured directly from the screen. For RMS voltage, which represents the effective voltage of an AC signal, we need to do a little math. Don't worry, it's easy. For a sine wave, the RMS voltage is simply the peak-to-peak voltage divided by 2 times the square root of 2. See, that wasn't so bad. Next up, frequency. Imagine the frequency of a sound wave. It's how many cycles occur per second. We measure frequency in hertz. The CRO helps us visualize and measure the frequency of electrical signals. First, adjust the horizontal scale, time division, to display a few cycles of the waveform. This allows us to clearly see the repeating pattern of the signal. Now measure the time period, t, which is the time it takes for one complete cycle. Calculating the frequency, f, is a breeze. It's simply the inverse of the time period, f equals 1 divided by t. For example, if the time period is 0.01 seconds, the frequency is 1 divided by 0.01, which equals 100 hertz. Easy peasy. Section 4. Unveiling phase relationships with a CRO. Now let's explore phase relationships, which tell us how two signals are aligned in time. Think of two people dancing. They can be in step, out of step, or somewhere in between. The CRO can reveal the phase difference between two signals. Connect the two signals to the CRO's inputs, one on the vertical axis and the other on the horizontal axis. This creates a lysogous figure, a pattern that reveals the phase relationship. A circle means the signals are 90 degrees out of phase, while a straight line indicates they are either in phase, 0 degrees, or completely out of phase, 180 degrees. By analyzing the lysogous figure, we can determine the phase difference between the signals. It's like decoding a secret message hidden within the dancing waves. Section 5. Essential tips for effective CRO operation. Here are some pro tips for using your CRO like a seasoned engineer. Calibration. Just like tuning a musical instrument, calibrating your CRO ensures accurate measurements. Probes. Choose the right probe for the job, just like you wouldn't use a hammer to turn a screw. Grounding. Proper grounding is crucial for safety and accurate measurements. Think of it like wearing a safety belt in a car. Triggering stabilizes the waveform on the screen, making it easier to analyze. It's like hitting pause on a fast-moving scene. By following these tips and practicing your CRO skills, you'll be well on your way to mastering this invaluable tool. Remember, knowledge is power, and with the CRO, you have the power to unravel the mysteries of the electrical world.